Okay, let's look at the increasing and the decreasing behavior of a function. All right, so here's the definition. All right, we say f is increasing on an open interval from a to b if x1 is smaller than x2. So as x value increases, the corresponding y value, which is f of x1 and f of x2, right? So f of x1 is a y value corresponding to x1, and f of x2 is a y value corresponding to x2. So as x value increases, y value also increases. Then we say function is increasing, right? And the function is called decreasing on an open interval from a to b if, as x value increases, the corresponding y value decreases, right? It's a simple concept that if you look at a picture, right? So increasing and decreasing. Increasing means just in picture wise, it's uphill. All right? And decreasing in a picture when you have a downhill. All right? So let's look at this picture here. Let's say this is a graph of, say, y equals f of x. All right? Then you see that this part from on the interval from negative infinity to a, which is this part, you see a uphill, right? So therefore the function is increasing here, right? After that you have a downhill, right? You can kind of visualize a skier facing in the positive x direction, right? Then so you are right here, then look at the hill. So this is uphill, so this is downhill between a and b, so you have a decreasing graph there, right? After that you have an uphill here, so this is going to be increasing there, right? After that it's going downhill, so it's going to be decreasing on that interval, right? So that's what increasing decreasing is, right? And when we talked about derivative, remember that the derivative tells you about so derivative f prime tells you about the slope of the tangent line or slope of the graph, right? So we can relate increasing decreasing behavior with the derivative, right? So here is the relationship, right? If the first derivative is positive, right, which means that the slope of the tangent line is positive, of course that relates to an uphill picture. So original function f is increasing. Right? If first derivative is negative, which means that the slope of the tangent line is negative, which means that f is decreasing. All right, so if you look at this picture, so on this interval, f prime is actually positive because it's increasing, and between a and b, f prime is negative, and between b and c, f prime is positive, and c and to positive infinity, f prime is negative, right? So there's a close relationship between the sign of the derivative and the increasing decreasing behavior of the original function. All right, so we know what happens when derivative is positive or negative. What if derivative is 0 or does not exist, right? That's where critical values come in, right? So here's the definition, right? Definition. C is a critical value of function f if, right, first condition, C has to be in the domain of f, right? So C has to be a value inside the domain of the function. And 2, right, they're either derivative at c is equal to 0, or derivative of the function at c does not exist. Right? So then we call c is a critical value of f. Right? So let's look at the picture. Right? So here, critical value is actually a. So a is called the critical value, since what happens to the tangent line here, right? So you have a horizontal tangent line, which means that at this point, the derivative at a is actually equal to 0, right? Because the horizontal line has a slope 0, right? There's another point, point C, B. B is another critical value because, again, it has a horizontal tangent line, which means that the derivative at B is equal to 0, right? And here's a last critical value, which is actually C. Right, at this point, you can see that it's got the sharp corner, so the derivative actually doesn't exist there because we can't really determine the tangent line there. So f prime of c actually does not exist, right, or undefined, right? So a, b, and c are called the critical values. So critical value are x equals a and b and c. Alright, that's that. Alright, so this is just the increasing decreasing behavior of the function, and we can actually determine increasing decreasing behavior by looking at the sign of the derivative. And we have critical values. Definition is critical value has to be in the domain of f, and either derivative equal to 0 there or derivative does not exist. Right? That's it. I hope that this was clear.